Hello dear friends, this is Dr. Vikas Radhav, Department of Statistics, Sanjivani Mahavidyalaya, Apollo. Welcome to our online class for B.Sc and B.Com first year, semester first. In yesterday class, we dealt with types of data, there is primary data and secondary data. And the difference between primary data and secondary data. After that, we discuss various scales, nominal scale, ordinal scales, ratio scale, interval scales, and distribution, frequency distribution with suitable examples. Dear students, today we are going to discuss the most important topic, that is graphical representation of data. Graphical representation of data is a very important topic for researcher, students, bank, industry, and actually the representation of a qualitative data suitably through chart and diagram is known as a graphical representation of statistical information. A geographical representation is the geometrical image of a set of data. Generally, graphs are used to represent mathematical relationship between two variables. Therefore, graphs are found to be of immense use in several fields to emphasize the facts. Banks, life insurance corporation, that is LIC, government agencies, industries use graph to show their growths, developments, extension, activities. Now, graphical representation of data by using histogram. Histogram is one of the popular used graph for the representation of frequency distribution. It is a series of adjacent rectangle on x-axis with class interval as base. Hence, with a rectangle is equal to class width, area of rectangle is taken as proportional to class frequencies. In case of inclusive method, the classification extended class interval is used as base, where extended class interval is an interval designated by class boundaries. Since the base of rectangle is class width, there is slight difference in the procedure of construction of histogram. When the classes are of equal width and when those are unequal width. In case of class of equal width, in this case, height of rectangle is proportional to the frequency. Similarly, in case of unequal, unequal. Actually here unequal width. In this case, height of rectangle is proportional to frequency density, where frequency density is equals to class frequency divided by the width. Let we show the a simple example of histogram. Example 1. Draw a histogram for the following distribution giving in marks obtained by 60 students in a class in a college. The marks, the data is 20 to 24, 25 to 29, 30 to 34, up to 50 to 54. Then corresponding number of students is the frequency. The number of students for the marks of first class, that is 20 to 24, is is the corresponding frequency 3, 25 to 29 the number of students 5, and last 50 to 54 the number of students 2. Here class interval. Here the class intervals given are of inclusive type. State the upper limit of a class interval is not equal. Here is not equal. It means there is no continuous data. Equal to the lower limit of its following class. The class boundaries will have to be determined. Then after adjustment the distribution will be show as the given table. Here we take the class interval that is continuous. The marks 19.5 to 24.5, again 24.5 to 29.5. So this is the continuous data for the 50 to 54. Okay, 59.5 to 54.5. Then there is no change for the corresponding frequencies. By using this continuous data and frequency, we plot the histogram by using where x-axis and y-axis, where x-axis is number of x-axis marks and y-axis number of students. As per the frequency, first one is a 3, the class interval 19.5. The first frequency is 3, second 5, third one is 12, and fourth one 18, up to the last one, that is class interval 49.5 to 5, that is 2. Okay. If you use the graph paper, then this is for very easy. You must write this scale. Here x-axis 1 centimeter is equals to 10 marks, 1 centimeter is equals to 10 marks, and y 1 centimeter axis, y-axis 1 centimeter is equals to 5 students. This is the 5, 10, 15, then 20. So this is the 5 students. So this is a simple example of histogram. Now we are going to discuss next topic, that is frequency polygon. Frequency polygon, it is the curve obtained by the joining the middle point of the top of the rectangle in a histogram by straight line. Mid value are taken on x-axis and frequency on y-axis to draw this graph. Successive points are joined by the line segment. Further, to complete polygon, we obtain closed figure by taking 2 or more classes on preceding to first class and others succeeding to the last class. Frequency of each of these classes is taken to be 0. The figure so obtained is called as frequency polygon. This is very important. This is also very important. Another one method for representing a frequency distribution of graph. Okay, we show the example of polygon. Draw a histogram and frequency polygon from the following distribution in marks of 15 students in statistics. Marks in statistics, this is continuous data 0 to 10 up to 80 to 19. Then the corresponding class frequency, the number of students, the class interval first, that is 0, 2, 3, 7, 13, 3, 9, 2 and 1. By using this table, as per the procedure, we draw in frequency polygon with histogram or histogram and frequency polygon. Here in this graph, we note that here we first draw histogram as per discussion of histogram topic. We first draw histogram and then the midpoint of the top of the bars are joined by the line segment to get the frequency polygon. So this is the, so these are the, so these points, this is 1, 2, 3, 4, 5, 6, 7, 8. These 8 points are the histogram, and these points is the including for the 0, that is 2, next and so on up to the here 90. So this is called as frequency polygon. As per in this graph, the x-axis marks again and y-axis number of students. We take the scale again as per the depend upon your graph paper. X and y-axis, 1 centimeter is equals to 10, 1 centimeter, that is x-axis, 1 centimeter is equals to 10 units, and y 1 centimeter is equals to, that is 2 units, that is 2, 4, 6, 8, the number of students. Okay, this is the simple example another for the frequency histogram with frequency polygon. A third one, frequency curve. Frequency curve is also known as smooth frequency curve. As per the name of smooth frequency curve, it is drawn by the freehand curve, through the various point of the polygon in such a way that the area include in just the same as that of polygon. It is known as a smooth frequency polygon. Let's study the following example of the concept of frequency curve. Draw a frequency curve for the following data. Age in years and number of students. The age 17 to last 31, the corresponding number of students 7, 13, 24, 30, 22, 15 and 6. As per this is the example. Here we will take age on horizontal axis, that is x-axis, and number of students on vertical axis. This is a simple example of frequency curve. It will plot the given frequency, number of students, again the midpoint on the given class interval, and then join the points by the freehand curve. First and